Welcome to this fascinating geometry challenge from the Stanford Math Tournament 2024. Today we're exploring the intriguing world of antiprisms and their volumes. Let's dive right in. Consider a prism with regular hexagonal bases. We form an antiprism by removing the lateral faces, rotating one of the bases 30 degrees about the axis passing through the centers of the bases, and forming 12 triangular faces between the bases, where each triangular face consists of one vertex of one of the bases and the two closest vertices of the other base. Compute the ratio of the volume of the antiprism to the volume of the original prism. Imagine flattening the antiprism so that both hexagonal bases lie in the same plane. This creates a dodecagon formed by the 12 vertices of the two hexagons. The area of the dodecagon base can be calculated using a simple formula: 12 times 1/2 times the square of the side length times the sine of 30 degrees. Simplifying, this gives us 3 times the square of the side length. This dodecagonal base will be the foundation of the new prism. The height of this new prism remains the same as the height of the original prism. Multiplying the area of the dodecagonal base by the height gives us the volume of the new prism, 3 times the square of the side length times the height. Next, we account for the 12 triangular pyramids that are formed by connecting the two bases of the antiprism. The height of each triangular face is given by the side length minus the altitude of an equilateral triangle, which simplifies to 2 minus the square root of 3, multiplied by the side length divided by 2. The volume of one triangular pyramid is 1/3, times its base area times its height. Summing up for all 12 pyramids, we find that their total volume is 2 minus the square root of 3, multiplied by the square of the side length times the height. Now, subtract the total volume of the triangular pyramids from the volume of the dodecagonal prism. This gives us the volume of the antiprism as 1 plus the square root of 3, multiplied by the square of the side length times the height. For comparison, the volume of the original prism with its regular hexagonal base is 3 times the square root of 3 divided by 2 multiplied by the square of the side length times the height. Finally, to find the ratio of the volumes, divide the volume of the antiprism by the volume of the original prism. Simplifying, the ratio becomes 2 times the square root of 3 plus 6 divided by 9. And there you have it. This problem is a perfect blend of spatial reasoning and algebraic manipulation, showcasing the beauty of geometry. Thank you for joining me on this mathematical journey.